straight into the questions. So this one is question 5 from 2012, and it's 5b. So let's read the question. We have a smooth sphere P collides with an identical smooth sphere Q, which is at rest. Immediately the masses are the same, and we know that the velocity of Q before impact is 0I plus 0J. Before impact, P makes an angle of alpha with the line of centers. So from that we can get the initial velocity for P. We know the initial velocity of Q. We also know that the I components will change because the line joining the centers is in that direction. And that gives me the following. So the initial velocity of P is going to be U cos alpha I plus U sin alpha j. Initial velocity of Q is 0I plus 0J. Obviously my A and B should be P and Q again. Second column, the masses are the same. In the third column, we know that the I's change, the J's stay the same, so instead of U cos alpha, I'll have V1, and U sin alpha will stay the same. And then the one below, instead of 0I, we have V2I, and the 0J stays the same. So then we apply our formula, Newton's elastic law, and the principle of conservation of momentum, put in the I components, and solve the simultaneous equations. It gives us V1 is equal to U cos alpha over 3. You'll notice here that there's no value for V2, and the reason for that is the deflected angle only pertains to sphere B, so the first sphere. Doesn't matter what happens with sphere Q in this particular question. So what I have now is the velocity of sphere P after the collision, which is U cos alpha over 3 in the I direction and U sin alpha in the J direction. Okay, we're told to show that tan theta is equal to that. Well, if we were to get the direction that sphere P travels after the collision, that would be tan of the angle that's denoted with the black dotted text, black dotted marker, I suppose. That would be equal to the J component over the I component. Or another way of putting it is the tan of alpha plus theta, because the sum of the two of them equals the total angle. So the tan of alpha plus theta equals U sin A all divided by U cos alpha over 3. So that's the first line in what we have. The second line, what they do is they go to the log tables and say the tan of alpha plus theta can be expanded to tan alpha plus tan theta all over 1 minus tan alpha by tan theta. And then likewise, the right hand side has been simplified. Instead of V1, they put in U cos alpha over 3, flip the fraction upside down and multiply by it. And what you end up with there is tan alpha plus tan theta is equal to 3 tan alpha minus 3 tan squared alpha by tan theta. Then your job is to bring everything with tan theta over onto the left hand side, take out a common factor of tan theta, and then divide under by it. And you end up with exactly what you're looking for. If you're having difficulty with that, I'd suggest pause the video and try the algebra yourself just to make sure you can do it.